Loss function, quality functional, and metric. Three levels of model evaluation. We already got how to use the loss function to evaluate the error of an algorithm for just one object. But how do we get an overall evaluation of the whole model performance? And the short answer is to count average for all losses. Basically, we use this kind of formula. We can see that for our loss function, we can see it here, this part that we already know. We put our target value for particular object and prediction function. This is whatever function that we use to predict our values. And what we have to do with that, we have to sum all of our objects together to sum their errors. Whatever we got, the whole errors, and then we have to divide the result by number of objects that we had in our data set. Basically, this is the formula and how we calculate average for all losses. And again, it looks like this. The short definition of the function is q, and the formula looks like this, as we already got it. And again, if we will go a little bit deeper, suppose we have two objects. We got a loss of 1 for the first and a loss of 9 for the second. So now we have totally two objects. So we sum them and divide them by 2, and we get quality function value 5. And if we used square deviation within our loss function, then after averaging, we will get something that is called mean squared error. And this something that we have to remember carefully. So key terms from here: quality functional, a measure of the overall quality of the model, and mean squared error, MSE, the average of the squared differences between predicted and actual values. So it's pretty easy stuff. Again, metric, a quality criterion that shows how well model predicts values for sample objects X. Metric coincides with the quality function. To summarize, what's the difference between all these terms? Metric vs quality functional vs a loss function. These three concepts are often confused and used together. And what's the difference between them? Loss function used for the error of a single object. Quality functional used for the average error across all objects used during model training. And metric used for the average measurement closer to the business task, used for presentations and model comparison. Key idea: metric is what you present to the client. It should be interpretable for ordinary people. In practice, loss quality function and metric can be the same, MSE, but in complex tasks, they usually different. Another example is face detection in photographs. The task is to find a person's face in a photograph, and there might be ID or answer, ground truth, model prediction, and we have to see how we can find if our model does great job. We can check it here. The closer our area of overlap to 1, the more accurate the prediction. So if intersection of a union is 0, they don't have overlap at all. Intersection over unimetric ranges from 0 to 1. This is not an error but a measure of quality. The higher the better. If you want to express it as a loss function, it will look like loss of intersection over union 1 minus intersection over union. So this will be a mistake if our intersection over union was less than 1. The lower we got, the better the model. Thank you.